Okay, so we're going to actually start implementing kind of the logic of our game right now. Our game's pretty functional. You can play around within it. And why is that broken all of a sudden? Okay, so it's pretty functional right now. What the hell? Wow, man. Really? Took the time to charm, and voila. Oh, do I miss Python, man? Oh, man, I miss Python so much. Okay, so it's pretty functional. You can play around with it. The only thing now is we actually have to implement the logic of the game. So, we have the turns change based on the player that's currently playing, but right now we actually have to implement logic and actually allow a game to actually come to an end by having one person win the game. So to do that, well, before we do that, I'm actually just going to clean up the code base just a little bit. So I'm just going to go ahead and start just chopping up and cleaning up a lot of our code. So let me just move all these guys to over here. Hold on. I think I prematurely got rid of some code that I actually need. So let's go grab it back. Okay, I'm going to need that to stay there for a second because I'm not done with it yet. So yeah, I don't think any of this is going to be in the. I don't think any of this is going to be in the recording. It's just way too long. Just cut to where everything's all cleaned up because there's also going to be a whole host of errors too. Yeah. Oh, we actually never actually initiate, or we never actually. Oh, genius, 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 genius. G state machine change play. There we go. The reason why is because I'm expecting a whole bunch of errors. Oh, there's no errors. Oh, interesting. So I can. Oh, well, look at that. I'm very suspicious that it worked on the first go, but hey. So we could clean this up a little bit more. I'm too lazy, so we're just not going to do that. Instead, what we're just going to do is we're actually going to focus on the meat of, or we're kind of trying to get to where we want to be as quickly as possible. Let's just get the logic up and running. Let's just actually start checking for a win at the end of every player's turn, and let's just start coding the AI. So let's say this is the tic tac toe grid. All right. So what we want to do is we want to take this, let's say this is the current active cell, right here. So then what we want to do is we want to tell the game, okay, so here's what you're going to do. You're going to look to every cell to the, yeah, I guess this is just how we're going to do it right now. You're going to look for every cell to the left, every cell up, every cell to the right, and every cell down. Now, if there are cases whereby, so let's look up. Oh, there's nothing up above us. So let's say this would be given that Lewis starts counting from one, which is very, very, very annoying. This would be index of 0, right? And then this is index of 1, there's an index of 2, there's an index of 3, 4, blah, 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 blah. So basically, if the index is between 1 and 3, then check 2 above, then check 1 above. Then, okay, well, because that's the only way you can get a match of 3, right? You start from 2 above, so which would be -1 here. This is not possible, right? That's an invalid starting position. Okay, so then perhaps the situation is you're in the middle of 3. So for example, if we were here, we'd be in the middle of a, if we ever got to here, which really should be very rare. But I'm doing this also keeping in mind that we're going to blow this up into 3D. So let's say we're here, and it's going to say, we want the computer to check for the possibility that this X here is actually the middle component within a match. So then it'll start looking up. It'll look down as well, with -1 and +1 within those indices. And the last thing it'll take a look at is whether or not there are just whether or not it's the beginning. So all of this is starting from the column, right? So am I at the bottom of the column, which would be the case if we were, say, starting from here. In that case, you look up 1, up 2, and then you check to see if there's a match there. However, you'd also want to check, well, what if we're in the middle of a match or middle of a well, I'm just going to call them matches for now. So if there's 3 X's in a row like this, let's just call this a match. I don't know why I'm calling it match. We're just going to call it a match. So if we're at the bottom of a match, we want to check the two rows above us. If we're in the middle, we want to check the one above us and the one below us. And if we're at the top, we just want to check the 2 below us. And so the way to do that is to just check in for every cell, check in all directions, check 2 above, 2 below, 2 to the right, 2 to the left. All right, and then for diagonals, we also want to do 2 within with each and every diagonal position, right? So we want to check, for example, if we're here, we want to check if there's a match in this cell, and then we want to check if there's a match in this cell, right? And so then we also want to do that in the opposite direction. We want to do that in this diagonal, and we also want to do that in this diagonal. And so anytime there's an invalid coordinate, there's no way there can be a match there, and we'll exit. Now, let's say, for example, we're at the bottom, we're over here again, right? Say we're at the bottom over here, and that we take a step upwards into this cell, and in this cell there actually happens to be a knot. So what the algorithm will do is say, okay, well, this is not equal to this. Therefore, quit searching for a match in this direction and then move to whichever the next programmatic direction that we have, right? So I guess to make this easy, we're just going to go clockwise, right? So we're going to start looking up first, and up 2 positions up, 1 position up, and then we're going to start moving around all of these and looking for matches in all different directions. I think that's a pretty solid game plan. It's probably going to fail, let's be honest, but let's just try it out and see how it goes. I feel like there's a very, very complicated, but you know what? We're sticking with it. Let's just print them out just so I ensure that everything's working. Huh? There's a 3? Where the heck are you finding a 3? Are you okay in the head? Oh, wait, well, first off, again, I think I'm just printing off the wrong thing, but where the hell it came up with a 3? I am confused. How the heck are you coming up with a 3? That's a 3. Okay, wait, so hold up, that just means that, means that there's going to be a lot more troubleshooting that I need to do, and this is why I printed out for a sanity check. In this case, a check that makes me go absolutely insane. Oh, that's printing something else. Oh, that's printing the mouse coordinates that I clicked on. Okay, that makes sense. What the hell is a 3? Okay, that makes sense. X is, 1, 2, 3, and Y is 1. Okay, that makes so much sense to me. So in position 1, 1, we have a 1. I'm assuming red is, red is 1, remember? 2, 1 is empty. 3, 1, we just placed a 1. 1, 2, 2, empty, 1. Okay, so it seems as if we should probably get rid of these guys. Okay, so let's actually start implementing the matching mechanism. Let's just do the vertical one first, and then we'll see what happens from there. So 2 spaces above. And that was a very, very annoying language that doesn't have a continue, but all right, we can build one ourselves. And okay, that's not bad. So let's see what happened here. So basically what it did was it said, so for this, then basically, only these bottom rows would be, you can check. So yeah, I guess it works. It works really, really well. Unfortunately, there's going to be some double checking that's going to happen with this algorithm. I don't really know what else to do right now then. But I guess what we could do though to optimize is, if you're already going to check the top here, then you don't really need to check the bottom again, right? If you already check this diagonal, you don't need to check that diagonal. If you check to the right, you don't need to check to the left. So I guess an optimization we can make is, you don't need the opposite direction. So we don't need this. We don't need this. We don't need this. Actually, no, I disagree. And what you could do is you could go without this, without this, without this, without that. So effectively, you start from the top left corner, and then you work your way down. Yeah, let's do that. Okay, so let's run that and see how that goes. So if I click here, yeah, it'll only check pretty much these columns just once. That's pretty much what we need to just do. Just check these columns one time. X1, Y1, X2. Okay. And so because we're checking and we're looping for Y in this case, or within the Y dimension in this case, we're going to call it, right? So I guess each one we could name the dimension or the direction. Let's just name them after a... I don't know what to name them. For now, let's just be safe. Let's call this the Y. Let's call this the X. No. Let's call this the 3 o'clock, the 4 o'clock, the 5 o'clock, and the 6 o'clock. Okay, so since we're checking the Y direction, now all we have to really do is we just have to loop over every single element within the Y. You know what? Let's just simplify it. Let's just simplify the heck out of all this. So you have your grid. Then what you could do is just pick a starting position. And this would be the same for all grids, right? So my starting position here would be, let's say here, let's say square 1, 1. And for every Y, all I'm going to be doing is, well, I'm just going to be looking down the column. And that's the same for 2D, and that's the same for 3D tic-tac-toe. The X's are the same. I just want to be looking along the X-axis here just to see if it's a match. Again, that will be virtually the same, whether it's 2D or 3D tic-tac-toe. The diagonals is where things get a little interesting, but pretty much it's kind of the same concept. Again, whether it's 2D or it's 3D tic-tac-toe, you just want to find a diagonal and just go down it. If there are three legal board positions, and let's say then here you want to go down. Oh well, there's no position here, so then this would be an invalid check. And then you do the same thing here. There are no positions outside the board here, so those two would be invalid checks. And then obviously you want it for the other side as well, like that. And that seems to be a much simpler solution than what we're taking a look at and what we're trying to do. So yeah, let's do that. I think actually we're going to do this if the current solution seems a little slow. I think let's go back to the original idea, which is to check in all directions. Let's just keep it as that, and then we'll optimize if we need it. Because I think it's a lot easier to scale that than... Okay, let's do that. See how that works. Of course, this is exactly what I are. Oh, sorry. Okay. So yeah, these are all the coordinates we'll be checking over. So basically now for all the Y coordinates that we have, we're just going to be going through and we're just going to be saying, get the ID of the first player we find and set that as the presumptive winning player or winner. And basically then we're just going to loop over every coordinate if it's equal, or the subsequent coordinates, if they're equal to the winning player, then we have a match. If one of them differs, then let's just quit and say, well, no, we do not have a match. Okay, and so this should not work because, well, we do not have a winning player. That's not working as well as I had hoped. How the hell do you have a winner already? Oh, it's because this keeps getting reset. That's probably why. Okay, that's probably why. Okay, let's try this instead now. Okay. Okay, that finally seems to work. Let's just get rid of this, just so it does not cause issues later. So we should not be checking if it's empty. And well, that's true. And there we go. Now we start checking 2. Okay. So basically we're just looping over every coordinate that we have determined from here. Right now we're just only looking at the y. Later on we're going to build it out such that it looks at the x and it looks at the diagonal as well. So then we just build out a list of coordinates. These coordinates, they'll just be the coordinates that we'll be taking a look at. So here we're just checking just to make sure that we have boxes or we have squares that are below us within the y direction. Then this table here builds out those coordinates, and then what we just do is we just say, okay, well, let's just let's assume that the current winner or the current whichever one we find within the top of the column is the current winner, and then for all the other coordinates we just list and we just say, okay, well, are you equal to the one before you? If so, if not, then we're gonna have to exit the loop. If so, then that truly is a winner. And if we have found our winner, then there's no point in continue looping over. We'll just completely exit that loop. So let's take a look now. Okay, it still seems to work. Okay, so that's just the x direction. We then need it for, sorry, that's just the y direction. We just need it for, we need it for x. We also need it for the diagonal, the 2 diagonals too. Okay, that's not bad. It's not bad at all. And now the only thing is to just get the diagonals. I minus 1, I minus 1. Let's test it out. Yeah, let's test it out, see how it goes. Oh, I'm forgetting to call it. That's why it's not showing anything. Player 1's turn. Player 2 goes there. Player 1 goes there. Player 2 goes there. No! Oh, you're checking the wrong. Let's just get rid of these. Okay, player 1 goes there. Player 2. There we go. Okay, that seems to work. And then we just need one more to go in the opposite direction. If I'm here, how do I get this coordinate? Well, this coordinate is 1 to the left and 1 down. So if I'm 3, 1, what I'm actually doing is I'm going 2, 2. Okay, that should work. Let's go ahead and try that. Oh, that does not work. Why does it not work? Ugh. It's this YX notation that keeps confusing me. Ugh, still not working. Oh, what am I doing? What am I doing? What am I doing? Okay, I see my mistake. Okay, there we go. That should have, oh, well, nope. It just broke everything. Oh, come on. Oh, because this is Y. And then this here is X. I hate this YX notation so bad. No, actually, this would just be -1. Yeah, because I already take care of the coordinate system. Winner's 1. There we go. Okay, let's test all of our matches. Nope. Let's do column. There we go. Winner's 1. Let's do this column. There we go. Winner's 1. And then this last column. There we go. Winner's 1. Alright, let's do row. There's 1, beautiful. Actually, let's do this instead, because I don't really want to see all these. I don't want to see anything. The only thing I really want to see is Okay, so now we have our game logic. Next thing we need to do is just add AI.